Good morning, everybody, and welcome to our webinar Wednesday on Wednesday. So happy short week this week. I hope everybody had a good long weekend, found something to do. It's actually getting warm here in Fargo, so I didn't even have to wear a jacket today, so that was exciting. So looking forward to the summer. I know everybody is going to be going to camp, having their activities, fairs, achievement days. So we're all about to get geared up. So this is our last webinar Wednesday we have scheduled right now because summer's fixing to kick into high gear, but it probably already has. So anyway, I just want to welcome everybody and welcome Margot Bowerman, our STEM specialist here, my colleague, and she's going to be talking to you about the field to fuel kits, learning how to make ethanol with your youth. So these are really cool kits I've seen sitting around her office. She's has packed up boxes around here. I've been packing up career boxes, so there's been lots of packaging going on around here. And so she's going to talk to you about this kit, and it's going to be a really good opportunity to learn about this activity that you can do with your youth. So I'm going to turn it over to Margot.
Well, thank you, Megan, and thanks to all of you for joining us while things are quite literally heating up. So thank you for your time here today. As we get started, if you wouldn't mind turning on your annotate feature and just letting me know where you are coming from. So again, you can find your annotate feature if you scroll on Zoom and click the annotate button, and it will allow you to put a little dot on the map of where you're coming from. And while you're doing that, and thank you for doing that, I'll just say a little bit about the Fields to Fuel curriculum. And one of the things that I like a lot of things about this, but one of the things I really love about this curriculum or this activity, this lesson, is that young people can actually see the chemistry that's happening right in front of them. Watching the balloons inflate or the bags expand creates this immediate excitement, and and curiosity that because they can see the reaction in front of them and it feels real and it feels visible. But what makes this activity especially powerful that it naturally goes from a demonstration and, oh, that's really cool, to authentic STEM learning. And once young people can see the differences in between their setups, if we're doing this as a group, they begin to ask those questions. They begin to think about how can I test different variables and how can I measure the results? And that's really what designing science investigations or engineering investigations is about. So they're playing the role of scientists and engineers. And then on top of that, here in North Dakota, this activity is connected to something that's very real in our own communities. Ethanol production connects agriculture and renewable energy, and it helps young people see how the science and engineering are part of the world around them. So appreciate all of you joining me here today, and thank you for letting me know where you're coming from. I'm just going to clear off our annotation. I appreciate all of you putting your mark on the map. I'm going to move us on. So what we're going to talk about today is I'm going to go over what the objectives of this activity that's part of the kit, the Fields and Fuel activity. I'm going to talk about what's in the kit, as well as go over a little bit of some background basics, but more importantly, how do we facilitate this activity with young people? And how do we spark that additional interest in continuing to go further in science and engineering investigation? And then I'll allow some time for questions, obviously. But I just want to quickly acknowledge that it was a really generous donation from Harvest Stone Low Carbon Partners that it's allowing us to produce these kits and help young people get interested in ethanol production. And if you haven't heard of Harvest Stone, they have the Blue Flint Refinery in Underwood, and they have Dakota Spirit in Spiritwood, and then they have another biorefinery in Indiana. So the objectives of this activity are to really understand and describe how biofuels are produced, and they're produced through fermentation, particularly how yeast converts that biomass, the sugars from that biomass into ethanol. And young people will then observe and measure the evidence of a chemical reaction, and they'll be able to identify what ethanol is as a chemical compound that's made of carbon, hydrogen, and oxygen. They'll get the opportunity to conduct a simple science investigation and also understand how enzymes can help to speed up a reaction. And as we're going through that as a facilitator, we want to call out some of the science and engineering practices that they're engaging in as they do this activity. And the one thing I'll mention too is this ethanol activity isn't a new activity to 4-H. It's been around for over a decade. What is I would hope is a twist to this activity now is that one, we're talking about science and engineering practices. So we're helping young people develop that identity as a scientist or engineer. And we're doing that through calling out those science and engineering activities, but we're also providing them with a workbook that will hopefully spark them to go a next step and do more science and engineering investigations. So as far as what's in the kit, there's some yeast, and it's not any special yeast. It's yeast you can get at the grocery store. The one thing that is probably the thing that's a little bit more difficult to obtain, but not impossible, is an enzyme. It's glucoamylase, and we'll talk a little bit about that. Then cornstarch, corn syrup, whole or cracked corn, some little snack bags, Ziploc snap bags, some measuring spoons, some plastic bottles, and balloons. So as you can see, most of these materials are things that a young person can go and get in their or their adults in their life can go and get for them. So you'll find that when I do science and engineering activities, I try and find activities that are easy, have materials that are fairly easy to obtain. And I will say, although the enzyme is not something you can typically buy in most places, you can also do this activity without the enzyme. So a little bit about the background. The North Dakota ethanol industry is a huge industry, and it's important. It's important to North Dakota. So there's the North Dakota Ethanol Council, and according to their statistics, it's a $1.7 billion addition to the state's economy. And of course, ethanol is a renewable fuel, and it's made from plant materials or biomass. And here in North Dakota, we're going to focus on the corn. Corn is the biomass. But the thing to note about ethanol is no matter what biomass, what plant biomass you use, it's still the same chemical formula. And I'm going to ask the facilitators to showcase a little bit of the chemical formulas, not because I want kids to be chemists or not because I'm hoping you can be a chemist, but I want to start introducing these things to young people so that they start to get some familiarity and have seen chemistry, and it will help them in school as they go on to these things. So ethanol is made by fermenting corn, and we use yeast. And again, it's the yeast that we're going to use in this experiment is nothing special. It's the same yeast that we use to make bread. But part of part of how that works, and this is a little bit of knowledge of how yeast works. The corn is made of starch, and so the yeast is going to consume that starch. But the starch are really molecules of glucose that are chained together. So yeast consumes that glucose, and the chemical reaction that happens, the glucose you can see there, has a six carbon ring, but the yeast breaks that down into to ethanol and carbon dioxide. And if you're using this activity with older youth, and there is in the activity some hints of how to make it a little easier for elementary school youth, but to make it for high school youth or older youth, I would encourage that you just to use this chemical formula because when we're doing chemistry, we want to account for all the molecules and the atoms. So this is a way for them to see how ethanol gets broken down into two molecules of ethanol and two carbon dioxide molecules. And what we're going to be paying attention to in this activity, although it's about ethanol, the thing that we're going to focus on in this activity is the carbon dioxide, and that's going to make this chemical reaction real and come to life for young people. The other thing, just as we get into this too, some of you are probably comfortable doing STEM programs, but I know that there's a lot of our staff and our volunteers that are uncomfortable with STEM programs. And so what I want you to take away too is you don't need to know everything to do a STEM program. And sometimes it's just as exciting and maybe even more powerful for young people if you come in with being uncomfortable with not knowing the answers. So you don't need to know the answers. And that will, at least in my experience, it sparks curiosity that is contagious for young people. So we want young people to see you being curious and not knowing the answers. And then the other thing, it's also really important that we do this for a variety of reasons. And one of those reasons is we're building those beyond ready skills, those skills that young people can demonstrate to employers that are valuable skills, so they can acknowledge and see the skills that they're developing. So as we facilitate a STEM activity, and young people sometimes have a misperception of STEM and scientists and engineers as they know everything. So we're gonna back down a little bit that, and we're gonna connect youth to the things that they already know. It's important to to have them some familiarity with the things they already know in order to build up new knowledge for them. So the first thing we're going to do is connect them to what they know about ethanol. Have they heard of it? How is it made? Why is it important to North Dakota? We're also, and I'll go through this in just a minute how we do this. We're also going to connect to glucose and have them either know remember what they know about glucose, or it may be a little bit of new knowledge. We're going to connect to carbon dioxide, something that most of the youth that I've worked with have heard of, and we're also going to connect it to yeast. So we're going to do it in this way. So we're going to talk about corn. Um, Corn, and most young people have seen corn. It contains a lot of starch, and starch is a molecule of glucose that are chained together. So the glucose is that ring. That's one molecule of glucose, and they're chained together to form a polymer. Now, I'm also not expecting young people to know some of this vocabulary, but again, I'm introducing some vocabulary. So a polymer is just molecules that are chained together. And in starch, in this case, it's molecules of glucose that are chained together. That's important for yeast because yeast uses the glucose. And the starch has to be broken down into glucose molecules in order for the yeast to use it. So as the yeast consumes the glucose for the energy, it breaks apart the glucose into ethanol and carbon dioxide. And so where have we heard the term yeast, or where have most people come across the term yeast? Almost all the young people, or many of the young people, and again, I'm targeting middle school with this, but most middle school youth have can associate yeast with bread. So we talk a little bit about what yeast is that it's a microorganism, it's a fungus. And when we buy it from the store, it's in a dormant stage. So there's a new vocabulary word. It's dormant, or it's just kind of resting in a stage where it's not doing anything. So part of what we do when we're making bread or when we're making the ethanol is we're going to wake it up with some warm water. I like to explain it as we're giving the yeast a nice little warm bath to wake them up. And so we talk about things, what do living things need? So yeast are now we've woken them up, they're going to need a little bit of food, and they're going to eat the glucose from the starch in the corn. In bread, they're getting the glucose in different areas. But we talk about yeast getting warm water, and here's a little bit of discussion. What do living things need? They don't want it too hot or too cold. They're a little bit like Goldilocks. So yeast needs some warm water to wake them up, and we want to give them some food. And again, what did we say? We want yeast to eat sugar, and so glucose is a sugar. So as bread expands, that's the yeast eating the glucose, producing ethanol and carbon dioxide. So when we bake the bread, those holes that we see in the bread, that's where the carbon dioxide was when the bread was baking. So we're connecting youth to knowledge they have with bread and yeast. And so talking a little bit now about carbon dioxide, most young people, when I say, what do you know about carbon dioxide? They'll be able to explain that it's something that we breathe out. That sometimes youth will even go the opposite. Well, it's something that plants take in. So yeah, so carbon dioxide is a gas, and that's what we want them to know. So when the yeast is working, the yeast is consuming the corn and breaking down that glucose molecule, they're making ethanol and carbon dioxide. So what would we see? We would see we'd see the gas being produced if we can capture that gas. And I also at this point I do write the the starch molecule on some white paper, or I'll come with some flip chart, and I want them to see the chemical, how it's represented in this state, because what we're showing them here when we're putting this ring formula together with what a glucose looks like is we're modeling a glucose. We can't actually see what a glucose molecule looks like. So this is what scientists and chemists, how they describe glucose in this molecular chain. And so this is a science and engineering practice of using a model to help us see what's going on. So um, it also helps connect young people to chemistry. But so this is even though I don't need them to know the chemistry behind this, I'm starting to introduce this now, and also explaining that we're using a model to understand what's happening, and that's what scientists and engineers do. So then, and we're getting close to the activity. So have you heard the term enzyme? And most young people haven't heard the term enzyme. And so just a simple explanation is an enzyme is a chemical that speeds up a chemical reaction. In this case, we're going to use the enzyme glucoamylase. And so you see the word glucose in there. So glucose is the chemical or the molecule that this enzyme is going to work on. And the word that ends in ase means it's going to chop it off. So we're going to chop off that end glucose. And so when we break off that end glucose molecule, that's what helps the yeast eat it. So we're cutting off that last glucose molecule and making that glucose molecule readily available for the yeast. So with that all laid out, now we actually get into the activity. And there's going to be two parts to this activity. There's one, we're going to start a investigation or start a chemical reaction in the snack bag. And I like the snack bag because it fills up kind of quickly. The small bag is better in this case. And so we have a simple recipe that we're going to use for both of our investigations. The second investigation is going to be the one that uses the bottle and the balloons. So the the basic recipe that we start with is 1 teaspoon of a food source. So the food source is going to be the corn. It's going to be either corn syrup, cornstarch, or some cracked or whole corn. And I let them choose what one they want to use. It's going to be a teaspoon of that. And then so 1 teaspoon of the food source and 1 teaspoon of the yeast. So that's a 1-to-1 ratio. Then we're going to use a 1/4 teaspoon of the glucoamylase and then a 1/4 cup of the warm water. So I was a little worried about putting this in a bag because I thought it would be really messy for kids, but actually that was not the messy part. But demonstrating how to put it in there. And I put all the dry ingredients in there and tell them to mix it up a little bit, and then we add the warm water. And so as we add the warm water, I've usually put the plastic bag on the flat surface, and I've been the one who's added the water, and I've also been the one that sealed it up, so I knew it was sealed well. The other advantage when I seal it up is I try and get as much of the air out as I possibly can because we're going to capture the carbon dioxide. So to see the carbon dioxide it really being formed, I'm trying to push all the air out, but it's not critical that you get all of the air out. But that is one thing that I do, and I haven't had any big messes. Um, the one thing that I've had to tell the young, so once you get the water in there, then you kind of got to mix it up. And so that's probably the hardest part is to gently, and I'm trying to tell them, be gentle to the yeast. So gently massage it. So you're just trying to get it so that all the dry ingredients have some type of moisture on there. And inevitably, um, they'll mix it, but they just can't stop. And I get it. They need something else to do. But what I tell them is, okay, now that you've got the yeast in there and everything's all mixed, now we just need the yeast to wake up and do their work. So leave your yeast alone, let them do their thing. And the what I really want to happen is lay your bag on the table, and when they leave it on the table, it'll start to form little tiny bubbles like carbon. It's the carbon dioxide, so it's kind of like what you'd see in soda, but they're little tiny bubbles. And if they leave it alone, they can start to see that fairly quickly. But if you start to mix it, the bubbles all get together and you don't see them. So I've probably said more times than I can count, okay, leave the bag alone. Okay, leave the bag alone. So that's just something that I've done. So after we've got that first experiment going, so we've got the bag there, I'll bring out, along with this activity is a workbook for them. And this workbook is designed to help them actually do a science experiment on their own. And so we'll bring that out and we'll start to walk through that. But at this point, I also want them to tap into their curiosity because that's how science investigations start, is because somebody had a question, wonder what happens with. So paying attention to that, the things they're wondering about are really critical for science. And I want young people to know that so that they keep that curiosity and wondering. And one of the best ways to do that is to lean into your own curiosity and wondering what's going to happen. And so being really clear, this is how science starts. So this project workbook will help them get started and going through there. But now we can actually move to the second investigation. And this is what I would call like the showy one. This is the one I want them to take home because it's a question grabber activity. So we're going to actually now do our investigation um, in the in the 16-ounce bottle, and we're going to capture the carbon dioxide with a balloon. So we'll talk about what we've done in the bag. And now I'm going to tell them choose your food source and let's think about doing something different. And so this is so they're going to do their investigation, a second investigation. So now we're going to talk about what do you want to do? What are you curious about? What are you wondering about? And let's see if we can answer that question. And inevitably with young people, they have a lot of questions, so they want to try a lot of things. Part of our job as the facilitator is to help them understand questions are great, but let's only let's only investigate one thing at a time. And talking them through the reason we're doing that is so that when we see a change, we can clearly point to it was that variable that made the difference. So that's one of the really important roles we have as a facilitator is acknowledging all the things they want to try, but having them slow down and only try one thing at a time. So this also is maybe a good time to talk about the different food sources. So we've got corn syrup, and talking about these food sources will also help them to perhaps make some predictions as well. So corn syrup is it's that thick sweetener that you get from the store, and you can show them the bottle, but it's mostly glucose. So what do we know about glucose? It's what the yeast eats. So in my mind, I would think this would be a really easy food for the yeast. Maybe they don't even need the enzyme. So I might plant that seed of, do they even need the enzyme if we're going to use corn syrup? But cornstarch is what's extracted from the grain, so it's more of a powder, and it's got some other things in there too. So, in my mind, and I don't know if this is true, and that's okay that I don't know the answer, it seems like cornstarch wouldn't have the glucose quite as readily available as corn syrup. And then we get to the cracked corn and the whole kernel corn, and it's not broken down. So, in my mind, it seems like this would take a long time for the yeast to get this one broken down, even with the enzyme. So we talk about that, and then I allow them to make their change and do their investigation. This is where the funnels are really important for getting the ingredients in the bottle. So the other thing I talk about too is once they've gotten what they want to try, or we've talked about as a group things that they want to try, is even though they have all these questions, we also have all of our colleagues and our partners in this room. They probably have similar questions as you. So maybe you can try changing this one variable and other people in the class can change another variable so that now we're using the power of all of us here in this room to answer more than one question. And now that also we've talked about the what the yeast food is or and when or that we've talked about the food source and different options they have to change it. We now want them to start to make a prediction. Okay, so how do you think this one is going to do compared to Susie's over here or Steve's over here? So start making some predictions about what's going to happen so that we're starting to have them think about what's going to happen, but also we're going to start to plant some seeds of why is it happening. So as we've done that, and maybe they've got their materials already, we're going to go back to the first experiment, our bag, and take a peek at the bag because by this time they'll start to see some of those little tiny bubbles, and some of the bags will have started to inflate. So really start to fill up with that carbon dioxide. And we talk again about what's happening here. Why is the bag inflating? It's the carbon dioxide that's inflating. So how do we know a chemical reaction is occurring? It's because we're seeing the bag inflate. So again, that's the carbon dioxide making the bag inflate. So how could we measure? And this is a hard question. I'll let them wrestle with this one for a while. How do we measure how much carbon dioxide we're collecting? So I might let them wrestle with that for a little bit. Let's think about how can we measure that? Because in science, if I want to see if my bag is doing better than Susie's, I want to be able to quantify that or add a measurement. So that's something that I want them again to sit and think about and problem solve. But you'll notice these bags do inflate, and kind of why I like the snack bags is because you do start to see it fairly quickly. So after they've got their second bottle going, and the one thing I will say too with the second bottle, and this is the only time I've really had messes, and it's been mostly on me, is when you're putting the balloon on the bottle, it's a tight fit, right? So the gas doesn't escape. So having somebody hold your bottle is really helpful so that you don't wear or put your experiment all over somebody else. So it's not that it can't be done, and sometimes kids will take that as a challenge, but it is really helpful to have a second person put the balloon on the bottle. But once they've got your balloon on the bottle and we've checked back in on the first bag, we'll start to see reactions happening. And the picture that's on the slide here is probably 30 minutes, 20 to 30 minutes after we've done the reactions. What they will see, if not the balloon inflating right away, they'll start to see the foam in the bottle. So that's what we talk about there. So we go through again, what's happening? And when I'm asking them these questions too, what's happening? I want them to use evidence. So how do you know that's happening? How can use evidence to tell me what's happening? There's a chemical reaction happening. How do you know? It's carbon dioxide. Well, how do you know? So helping them walk through some of those explanations. And this is also a science and engineering practice of being able to analyze and interpret data, but also being able to make a statement using evidence and not just opinion. So at this stage too, I'll start to talk about really get into how do we measure what's happening. And this is really more important for older youth because we're starting to get into some of that math and computational thinking. So how could we measure what's happening? For the plastic bag, I don't not too many young people have figured out we're going to measure the height, and the easy way to measure the height is just to put an index card or something stiff on the top and measure the height that it's rising. So that's one way we could measure, and I could see if my bag has got more in it than my neighbors. It's not a perfect science, but it starts to introduce the concept of adding a numerical value. With the balloons, how could we measure how much carbon dioxide is in the balloons? How can we see whose is bigger than the other? And one way we could do that, or we could measure how big it's getting over time, is to measure their circumference. And while a balloon isn't a perfect sphere, there are measurements for the volume of a sphere. But how would you measure the circumference of a balloon? And so I will have some string available. We usually haven't had time in just an hour, but to put the string around the largest part of the balloon, and again have somebody help you mark on the string where the string overlaps, and then you've got the circumference of your balloon. So that part's not as critical, but it's something I do want them to start thinking about because being able to quantify and add measurements are an important part of science. If you do have more than an hour with your group, there is an optional activity in there that comes from Nourish the Future, and it's called Ticketace. And you'll need tear-off tickets, so this does not come as part of the kit. But this is an activity to understand how enzymes, how they work on, at least in this case, complex sugars like starch, and how the concentration of the enzyme or the concentration of what it's working on can affect the rate of the enzyme activity. So to end the activity, we've got our balloons. They're starting to inflate. The bags are getting bigger. Sometimes I will just as an activity to show young people chemically how to smell a chemical. I will first preface it with saying this is not what we're going to um, let out of these bags as carbon dioxide, so it's not a dangerous chemical. Nonetheless, we don't want to stick our nose in it to see what it's like. So I demonstrate kind of the idea of wafting. So I'll open the bag a little bit and waft. It's not a great smell. It does not smell like bread baking, so it's not that pleasant yeast smell, but it's a good opportunity to show them another scientific observation skill. The other thing too is I don't want them taking the snack bags home because they will inflate to where they look like they're going to pop, and I'm not going to be responsible for any of those messes. So as we're wrapping up, I'll start to ask, so which corn product do you think is easiest for the yeast to use to make ethanol? And why do you think that? I'll ask them too, was the enzyme important? And this is maybe a bit of a trick question because I've not had any youth that haven't used the enzyme. So they can't tell me an evidence-based reason of why the enzyme was important. They can use the modeling. What I really want them to do is test, is the enzyme necessary? So I'm planting some seeds for them to do their activity on their own. See what happens if you don't add the enzyme. The other thing that I found really curious is in my mind, I've made the prediction that the cracked corn should take longer than corn syrup or cornstarch. And there have been a few cases, it's not a regular occurrence, where actually the balloon inflated quicker with the cracked corn. And that's a mystery to me, and it amazes me. And so I'm not going to hide that curiosity and amazement. I'm not afraid that my prediction is wrong. That's also a really important skill for young people to realize is it's okay if your prediction is wrong. That's how we learn. So I admit that I have some curiosity here of why the cracked corn is doing so well compared to some of the others. And I still don't know the answer to that, and that's okay. But I'll also leave them at what other questions do you still have? Again, because I really want them to take that workbook home, see that they have easy materials to do more chemical reaction experiments. And then just in the final closing, and you'll see in the activity, there's a few general reflection questions. There's also some connections to different careers. And I also want them also to think about, okay, you've done this science experiment, you've taken this project and you've actually done a few other science experiments. Where can you go with that? So our county fair, this would be an appropriate place to exhibit this under the physical science or the physical science chemistry class. Or I'd love to see some of our 4-Hers. I've seen some, but I'd like to see more of our 4-Hers at one of our science fairs. So with that, I'm hoping what you take away from today is that this activity, it's more than just an ethanol activity. It's an opportunity for young people to experience those science and engineering practices, something that they can see, something they can test, and something that they can question and investigate for themselves, all while we're connecting it to agriculture, something that's critically important here and happening right here in North Dakota. And with that, if you guys have any questions, I'd love to answer questions. Oh, Monica, I love that. And that is something. So Monica, it's the variety of corn sometimes might have a higher starch or the sugar concentration. That would be something I would love to see young people test. And really, that's true science. Like what corn is best for ethanol production. Thank you, Monica. Awesome. Other questions?
I'm Hey Margaret, I'm kind of interested who all has gotten the kits and has used it out there and their experiences.
Yeah. Has anybody used their kits yet?
Because people picked them up at spring conference.
Right.
We see a question from
Yep. Where is the enzyme add-on activity? So it's right built in the lesson. If you go in there, there should be a link for the ticketase activity. If you're struggling to find it, let me know and I'll shoot you a PDF. But you will need the tear off tickets. Love to hear it. I'd love to hear differences in variety of corn. Thanks, Dustin. Is there anybody out there that didn't get a kit that would like one? I've had a little bit of interest from some individual 4-Hers, so I, I don't have the capacity to do a ton of kits, but I'm also contemplating doing some individual kits so that a young person can go and do this on their own. So a young person who's really interested in doing some further investigation.
Speaking of investigation, if you could send me a 50-pound bag of those salted and roasted corn snacks, I think
Oh
that
my
would
gosh.
really
Yeah, me too.
push me towards doing more of the investigations.
Yeah, same. And so I got those from the Corn Council, and the idea for that came when I did it so your local Corn Council actually may be able to hook you up with that.
You can just email the Corn Council because when I do my egg in the classroom lesson for February, we do corn and I get the corn pencils, the corn snacks, and these really cute corn erasers. They're shaped like corn. They send me other stuff too. I can't even remember, but they got lots of it.
Awesome. Thanks, Monica.
And I see you, Sarah, Ramsey County. I'll do another kit. I'll do some more kits. So why I'm asking if you and perhaps since we're not getting a lot of kits, if or a lot of the simplest way to say this, I have some money to make more kits. So if you'd like another kit, let me know. Well, with no other questions, like I said, I know it's heating up and not just the temperature, so I want to be respectful of your time. You can email me independently as well. Thank you all for being here today, and I hope to hear how you've used the kit. And there is a evaluation in there, and so if you could get some data, that would help me make the case to Harvest Stone as well. So thank you all for being here today, and enjoy the rest of your summer.
Yeah, thank you
Megan?
everybody. I'll send this out and include the resources, the link to the resources that Margot has. So, and let us know if you have any questions. Thank you. Bye.